Hello everybody, welcome to this amazing channel One Math Army. As you all know, I am Mohammad Taqi Hassan, your maths mentor at this channel. Now, you all know that the chapter sequences and series is going on related to class 11th, and we have already completed arithmetic progression and are in the second part of geometric progression. In this session, we are going to learn about insertion of geometric means between two given numbers. In the previous session we have learned about properties of geometric progression. You can check that video, it's given in the link in the description below, and hopefully next we will solve problems on geometric progression, and after that we'll go on to harmonic progression. Before that, let's congratulate those who gave the correct answer to the previous session's homework question. Well, it's myself. Sadly, no one was able to give the answer correctly. I was the only one who got it right. Well, I was the only one who knew the answer. So now let's see how I did that. So this is our question. A square is drawn by joining the midpoints of the sides of a given square. A third square is drawn inside the second square. In the same way, this process continues indefinitely. If a side of the first square is 16 centimeters, then the sum of the areas of all the square is. So we have a square of 16 centimeters each side, and we have another square joining, which comes by joining the midpoints of all the four lines, and inside that the same process goes on and goes on until we get a eeny meeny square which has a negligible value. Now we need to find the value of this side over here, right? So most of you mistaken it as 16 by 2 8, but it is not 8, it is a by root 2. And let's see how I got that. First we are going to find the square area of each square, then we are going to go on how many squares we are going to add, and just going to substitute the values. So it's basically finding the value of the first term and the common ratio, and after that it's simple. Now say we have this square. This is a square over here of side A, and I have joined the four midpoints to form another triangle inside, and in a square all the four sides are equal, as everyone knows, and all the angles are right angles, means they are 90 degrees. Now I'm joining the midpoints, right? So this point over here divides this line into two equal parts, a by 2 and a by 2. Similarly, if this is a by 2 and a by 2, this is also a by 2. So all of these are small parts, like this one, this one, this one, this one, this one, are all are a by 2. Now let's just consider 1 2 adjacent and perpendicular a by 2. So I'm going to take this one. So I have this side over here and this side over here, this side over here. So these two sides, right? And I know that this angle over here is 90 degrees. This angle over here is 90 degrees. So just apply the Pythagoras theorem. This side over here, let me just shade that in red. Just wait a second. This thing. This is the hypotenuse of this triangle. If you just flip that over, that will become the hypotenuse of the triangle, and it's actually very simple, because if in a right angle triangle, if the two smaller sides are equal, then obviously then the third side will just be the sum of them into root 2, right? So this will be 45, this will be 45, and eventually I'm going to get this as a by root 2. We're going to get that as a by root 2. So this is a by root 2, this is a by root 2, this is a by root 2, and this is a by root 2. Now let's assume that a by root 2 is a1. Let's assume that a by root 2 is a1 or a2, whatever. Just take it as another term, a simpler term. And now forget about the bigger square out there. Just rotate this 45 degrees and think another square is going to come there, right? another square. Assuming that a by root 2 is a1, another square of side a1 by root 2 will appear here. So that's what is given in the question. The squares are going on till they're very tiny, very small, and in negligible. They're in a negligible value, right? So the common difference over here is 1 by 2. Yeah, you might think root 2, but we're finding the sum of the areas of the square, right? So this area of the bigger square over here is a square plus a2 square, which is a by root 2 whole square. Again 16 by root 2 is 8 root 2. What we have to do is divide it by 2 and multiply with the root 2, because root 2 by 2 is nothing but root 2. Sorry. Yeah. 2 divided by root 2 is nothing but root 2. So I'm going to get this series over here, 16 square plus 8 root 2 whole square plus 8 square, and so on up to a tiny value. And this is your geometric progression. So this is 256, this is 128. The common ratio is 1 by 2. This is 128 and this is 64. The common ratio is 1 by 2. And that's what we wrote here. Common ratio is 1 by 2, and the first term 16 square is 256. Now the sum for the infinite terms of a GP is a by 1 minus r, and the value of a is 256, and the value of r is 1 by 2. 1 minus 1 by 2 is nothing but 1 by 2, and multiply both sides with 2. The 1 by 2 in the bottom will get cancelled out, and 256 into 2 is 512. So that's our answer. And here r should always be less than 1. Always be less than 1. Why do you think it should be less than 1? Some may think that if r is greater than 1, then this thing over here will be negative. So there's no problem of sum of infinite terms of a GP being negative. The problem is, if the value of r is greater than 1, then the GP will keep increasing, right? So if I have, say, 1 and the common difference is 4, and it's going for infinite, so I have the first term 4, the next term first term 1, the second term 4, the second term 16, and it's growing on, and obviously the sum will be infinite. So we are using this formula for a decreasing GP but not an increasing GP. If you multiply that, it's going to be increasing. If we divide that, it's going to be decreasing. Now you already know that we completed arithmetic progression. Let me just get rid of the line there. Wait a second. Okay, now and geometric progression, we are discussing it right now. There is one concept left, and this is the last for today. Now if 3 terms of a geometric progression, if 3 terms are in geometric progression, say ABC, then the middle term is called the geometric mean between the two. A, this is C, this is B in the middle, are in GP. Then B is root AC. Is the geometric mean of AC. So this is also the geometric mean of AC, right? So in arithmetic progression, it is addition and subtraction. So it is 2B equals to A plus C. So here it's not like that. So take A by R, A and AR. So B square, which is A square, equals to A into C. The R's get cancelled out here, and the A remain. So A square. So I've told you in the previous session that we will discuss how we got this thing in this session, and that's completed. If a1, a2 and so on an are non-zero positive numbers, so they're non-zero and non-negative too, they're just positive. Yeah, we no need to mention this non-zero over here, because positive does not include 0, right? Then their geometric mean G, we are representing the geometric mean G, is given by a1 into a2 into a3 and so on into a and whole to the power of 1 by, and that's what we did here. Here we have only 3 terms. Yeah, we have 3 terms over here, and the value of n is 2. So that will be yeah, no, that's different. That is different. This is after inserting n geometric means in between 2 numbers, and the product, their whole mean, the single mean between the two numbers is given by the first mean into second mean into third mean up to how many geometric means they are, whole to the power of 1 by the number of means, nothing but the nth root of product of the means, where n is the number of means. Now if g1, g2 and g3 and so on, gn are n arithmetic means between a and b, ag1, ag2, ag3 and so on, agn comma b will be a gp. Obviously we know that, that's the condition. And here a is the first term, b is the n plus 2th term, because there are n terms in the middle. This is the first term, so n plus 1th term up to here, and this is the n plus 2nd term, will be a gp. And here the value of the last number b equals to a into r to the power of n plus 1. We get that using this over here. It's nothing but the simplification of this. R equals to n plus 1th root of b by a, which gives that which means that the value of g1 is ar, also equal to a into b by a to the power of 1 minus 1 by n plus 1. And similarly the value of g2 will be ar square, which is equal to a into b by a whole to the power of 2 by n plus 1, and so on. The value of gn will be ar to the power of n, which is a into b by a whole to the power of n by n plus 1. So that's our third property, and our fourth property is our last property, I guess. Yeah, that's our last property. g1, g2, g3, g4 and so on, gn equals to root ab to the power of n, which equals to gn. So this is not a comma, this is multiplication. It's a multiplication over here. Now if I multiply all the geometric means in between two numbers, I'm going to get the single geometric mean between those two numbers to the power of number of geometric means. So nothing but root of ab whole to the power of n, root of ab whole to the power of n. That is exactly what we done over here, right? The number of means inserted between a and c is 1, so the value of n is 1. Here the value of a is a and the value of b is c, right? So we got this equation right over here, that's explains it completely, right? It's root of ab, so g equals to gn equals to g to the power of n equals to root of ab whole to the power of n. The value of b is c, the value of a is a, and the value of n is 1, right? And this is g power n, by the way. Now if you want that in text, that is, if n geometric means are inserted between two quantities, then the product of n geometric means in the nth power of a single geometric mean between two quantities. Now I have a surprise for you, and this is the surprise. I won't be solving any problem for trial, just to show how it works, but this time you are going to get I'm going to give you 4 nice questions that I found, and you have to do it on your own. So let's see how many of you does them, and give the answers in the comment below, and give them order wise, right? If you didn't get the second one, don't mark the third one as the second, just write 1, 2, 3 like that in order, right? Now till then, bye bye guys. I'll meet you in the next session. Hopefully there we will be doing problems on geometric progression. Yeah, mostly there will be previous IIT questions or important questions related to this topic. Bye bye. I'll meet you in the next session.